Well, hello friends. Today we are going to work a little bit on the browser, and we're going to be putting images into canvases using the draw image element into canvas API. And I guess we'll just start by making a little test for this so that we know what we're working with. So we'll put it in the usual spot, image canvas, and start with the usual boilerplate. I'm getting a little bit better at typing this boilerplate. So we'll need a canvas, say 400 by 400, and we will need an image element with some image. So I guess we can, maybe we can use some icon, for example, like the buggy icon. Yeah, I think that'll do it. And then we'll need a script. So let's say that event listener load. And when we loaded, we should get a 2D canvas context. So let's do query selector all this time. Normally I use get element by ID, but why don't we switch it up? So we'll look for all the canvases and grab the first one and say get context 2D. Okay, getting a little too small here. And then we'll also grab the image. And I guess then we can just draw the image into the canvas. I think this is how you do it. You give like an offset. So let's try this out. Oh wait, it was called image canvas. Okay, that doesn't look quite right. Hold on, am I forgetting something here? Let's style that canvas so we can see where it is, because we'll just do solid black. Solid black. I have a friend whose name is Solid Black. Anyway, we can see here that it doesn't paint. Maybe that's because, I don't know, probably I'm doing something wrong. Maybe the tools can tell me what am I doing wrong. Nothing. Alright. Alert img. Oh wait, I want to see. No, I'm not even running this code. Wait. Oh, because it's a window. It's a window event, right? Yeah. But we don't actually have events on window yet, so we'll have to use DOM content loaded, because that's what we support in Serenity. And that's not going to work because the image is not loaded yet. So we actually need to do this when the image has finished loading. So this will get a little bit murky here, but I'm sure there are easier ways to do this if you have more of the web API available, but we'll work with what we have. So when the image says he's loaded, then we can draw the image then. Okay, there we go. That's pretty good. And you know what? Why not, for fun? Let's scale up the thing so that we can test out the scaling code a little bit. And let's also, I was thinking, let's put some background on this thing. So fill style is a cool number, and fill rect with a cool rect. 400 by 400. Zoom. All right, so that's pretty cool. And this is going to take quite a bit of work, but let's get this to the point where we can open it in Serenity. So, or we can open it and it actually renders this way, minus the smoothing of this bitmap, because we're not going to do interpolation scaling. So let's see what this comes out as right now. Image canvas. All right, so the basic concept is here, but we don't know how to. I already forgot. We don't do the load event for images, so that's not going to work. Yeah, this thing is not going to fire, and this thing will work. It should work, and we don't have the load event, and then we don't have drawImage, but the rest is okay, I think. So let's get cracking. The first thing we'll do, I think, is just add a load event for images. So we'll alert when that happens so that we can celebrate. And then I think, so image element, the load of the image is driven by the DOM element right now. So what happens is, when we parse the attributes of an image element and we encounter the source attribute that we call load image, and then load image fires off an asynchronous resource load. And in the callback, it will create a decoder and potentially relay out and re-render the page, right? So I think essentially when we get this is a callback, a success callback. So I think basically this is where we want to fire a load event. So we'll just say dispatch event create load. It might be that simple, actually, at least for our current purposes. So maybe we should, let's make that the default browser start page, just for comfort. And let's go into user space mode. All right. Yeah, get one of those big, nice command lines that compiles all the stuff we care about, and then installs it and runs it. Poof! Image loaded. Look at that. He does not look good down here, by the way. Oh, that's so weird. I guess because we do the alert in response to the event here. So maybe for fidelity's sake, let's reorder this a little bit. This needs to be structured in a slightly different way to be more correct, but for now, let's just do the event dispatch last, because an issue that we have with event dispatch in libweb right now is that it is always synchronous. So whenever you call dispatch event, the engine is going to drop what he's doing and just fire any event handlers that you have for that event, which is very often not what you want. You want to get back to the event loop and finish any like JavaScript and stuff that you might be working on, any layout you might be working on. And then once you get back to the event loop, then you want to dispatch the event. So this thing needs to be turned into a queuing mechanism and so on. But right now it's like this. So we just deal with it. But anyway, we got our load event. So that's progress. So let's just commit that right away because it's so simple. Excuse me. Dispatch a load event on HTML image element. Yeah, it's really straightforward. Probably it should. I would have. Let's look at the MDN and see what they say about load event, because I'm sure that they have some more stuff. Load event. image element. There might be some more stuff that should be on that thing. Where can I see events? Okay, I don't know where to look this up right now, and I don't want to go digging in the specs, so let's just push forward instead. So this means that we have the load event, and now we're just missing drawImage, right? So in Canvas rendering context 2D wrapper, which is our JavaScript implementation object, we'll put a new native function called drawImage, handled by drawImage. And I think it takes 5 parameters, because there's the image, and then X and Y, and then an optional width and height. I think. It comes in a bunch of different configurations. Actually, maybe we can ask Firefox about this. Let's see, give me a console. Document, get query selector. Canvas, get context 2D, and draw image dot length 3. Okay, all right, my bad. 3 then. Then that's at least corrector. So I think we'll put him up here. drawImage. Okay. So if we go back to, or maybe we never went there actually. Yeah, this is what I want. Good guess. Bing. So the API is, actually it's even more optional here that you could pass. So I guess it's a source and destination rect. If you wanted to go all out, you can say like this part of the source into this part of the destination, and then you scale based on that. But we will focus on this API right now. So let's see. That means that I want to put it next to stroke rect here. Canvas rendering context 2D wrapper. drawImage interpreter. First thing is we need to verify that we actually have the right kind of JavaScript object. Otherwise, if you're calling this on something that's not a Canvas rendering context, we'll say no, no, no. And then let's do this little thing here where we get a handy handle on the arguments. So if arguments size is less than 3, which is our minimum, we will throw a type error. Draw image needs more arguments. I don't know, we should have nice consistent strings for these at some point, and maybe this is not even the right thing to express here, because like the problem isn't that there are arguments missing, but like that the arguments are of the wrong type or whatever. Anyway, it gets the point across for now. So now we can say that the first argument needs to be an image, and it needs to be an HTML image element, and we definitely don't have a wrapper for that. The only HTML element that we wrap is canvas elements, so we're gonna have to add new wrappers for the image element. So libjs, no, libweb bindings. I think we'll start based on the canvas element wrapper. So we'll do this. And then we can just add him here. Image element wrapper. And let's do all of this correctly now. So this is an image element wrapper, which wraps an image element and can give you an image element. And let's get rid of these things for now. And I don't know why you don't like this. Maybe we need it here. So HTML image element. Let's just add it to the list of forward declarations. Wrapper. Okay, yeah, that did the trick. And then in here, let's just do a search and replace. Clickety-clack. And get rid of all of these guys. And get rid of these thingamajigs. All right. And actually, we don't need any of these either. So it's just to make sure that we have a particular kind of object, an identifiable object that represents an image element, so that we can verify that we're using the right type of thing in the drawImage implementation. So okay, so now we have that. I guess we need to also make sure that when instantiating a JavaScript wrapper for an image element, we have to say the wrapper type is bindings image element wrapper. And we need to teach this function here to create the right type. All right. And oh, and we need some a little bit more stuff. I need to start generating this. It keeps growing, but it's okay for now. It's just gonna keep growing until I decide to generate it. I feel like I want to learn a little bit more about the needs before I start writing the generator. But I can't postpone it forever. So now we'll generate an image element wrapper for that image element, and it will be able to identify it based on the class name string. So that's how we can identify him at the moment. We could, no, let's use that for now. So if arguments 0 to object, image argument is arguments 0 to object interpreter. Wait, how do you call this? Oh, heap. Heap. I can't go. Oh, okay. Okay. So toObject will give me a pointer, and it may fail. So we need to do an exception check in case it fails, because toObject can call arbitrary code, right? So you have to do an exception check. And the way we do it is we just check the pointer that was returned. And if it's null, then we know we have to bail out, because then the engine has an exception. Otherwise, we'll have a valid pointer. And if it's a valid pointer, we know that it points to an object. So now we can start to check if the image argument class name is, this is a little bit gunky to do a string check here. I would like to put this into some templated helper, but right now we're just going to do it this way. comparing two literals here. That's a bit gross. String view, can we do that? Can't get away that cheap. How about if I string viewize this guy? All right. Eesh. So if this is not a match, then we will, I think we need to throw another type error. It's an image. I need image is not an HTML image element. All right. But then if it is, then because X is image, oh no, it's arguments 1, 2 double. Oh, where did I go? Where are we? Here we are. X and Y are arguments 1 and 2. And then all we gotta do now is call drawImage on the C++ implementation object, which we didn't do anything with yet. But we'll pass him the image argument, which is a, now we know this to be an image element wrapper. So we can take a const image element wrapper dot, oh, we need to include some stuff for that to work. libweb dom image element and also bindings image element wrapper. All right, so dot node X and Y, and then this will just return undefined, I think. Return, they don't even mention some return value here, so let's just assume that undefined is okay. I think, oh, you're supposed to throw an exception here if the image is not loaded, which makes sense, but let's not worry about that right now. Let's just get it drawing. So now we'll need to add it to the HTML canvas element C++ object, which needs this API, or rather, actually, I'm not calling this on the canvas element. I'm calling it on the rendering context. So the 2D context object in C++ needs a draw image, and we'll get an image element like this and some floats. So it's a little bit weird. Like in the JavaScript engine, we use doubles for all of the floating point values, and then in the web engine, we're only using floats. That's purely a space saving issue. We could probably switch to using doubles, but I don't know. It seems sufficient to me to use floats for layout and rendering and stuff. But maybe there's some good reason to use doubles here. In JavaScript, we just use doubles for correctness, because it's like highly specified how it needs to work. Anyway, let's get this thing working. So in the most fanciest of classes, rendering context 2D. Here we'll call this image element, and I think we'll need to include him so that we can peek into his innards. Alright, so what we want to do now is we want to first we want to transform the destination rect. So the rect is going to be X and Y. That's the that's the offset of the rect, but then the size of the rect is going to be automatically determined based on the image. So we have to actually get the rect from the image. Image element dot. Can we just get the image? Is this how we get it? No, we have a bitmap getter. Okay, so I guess we can say if image, if there's no bitmap, sorry dude, we cannot help you in that case. But if there is a bitmap, we will happily grab his rect. And then we will transform that. I guess wait, hold on. It's destination rect is, let's just call it dest rect. Let's not be savages. Like source rect and destination rect. These are some abbreviations I'm okay with because they're so prevalent. So this will be X and Y, and the image element bitmap X, no, size, no, width, and the image element bitmap height. All right, there we go. Oh, and you don't know that I'm making a rect here. And you don't know that I want a float rect. Flowat rect. And you still don't like me because I didn't qualify it. And then these guys are integers, so we got a cast. All right. Have you hassled me enough, compiler? Then we just have to remap the rect into the transformed coordinate space, and finally call painter draw scaled bitmap destination rect image element bitmap source rect, and wait, dst rect is, what am I even doing wrong here? Reference to a non-static member function. Did I make this static or something? No. Okay, what am I missing here? That's something obvious, but what is it? Oh, it's expecting an interact. There we go. And the painter, oh, we didn't even fetch a painter. So the way we fetch a painter is to just say, give me the painter. If we don't get a painter, that means that we are not in the, we're not in the document. So like a canvas element can exist outside of the document, right? Like if you just instantiate a canvas element and then you can ask it for a rendering context. But then when you try to draw into that, we currently don't support off-screen canvases. So we just fail. Or like we just silently do nothing, actually. So let's try this out. I am feeling mildly confident that this might do something. We are missing something in 2D wrapper on line 99. I can't throw this exception because I am using a forward declaration of the exception. That's my bad. Man, this engine keeps growing and growing and growing. I miss when it used to take a second to compile the web engine, or like 2 seconds to compile the whole operating system. Those were the days. But in many ways, these are also the days, so I'm not complaining. Image loaded, and we got gray, but then we got nothing. So reference error, IMG not known. Okay, all right. So what's wrong with it? IMG. Oh shit, I went into the trap. I'm trying to use IMG here, even though it's defined or declared here, and we don't have closure implementation yet. So there's no closure of IMG inside of this function here. So we'll cheat and make it a global. So we can just remove the var actually and make it a global thingy. All right. It's a little cheap, but I keep postponing implementing closures and activations and stuff because I need to put some time in and actually understand how it should work. So image loaded and still no go. Image is not an HTML image element. All right, well, why not? So the image argument is not an image element wrapper. So I wonder what it is then. We can actually tell you this. If we use string format, class name, this is like an excessively specific error message, right? Like, probably we shouldn't keep it that way. And we should get rid of the alert. Okay, so he just says it's not an image element, it's an element wrapper. Okay, so how did we mess that up? I thought we did this correctly. Let's see. If is image element node. Oh, maybe we don't implement is image element. We don't. Inline bool is HTML image element. Const node. I have to peek at how these look like. Yeah, like this. So image element checks if the tag name ignoring case is IMG. And then we have to rebuild it a little bit because many people apparently include the image element header. Clickety-clack, and look at that. That's pretty cool. I would say that is not bad at all. I feel like the pixel sizes are a little off. Oh, I was zoomed here in Firefox. See? Look at that fidelity. I actually think this looks better pixelated. I was never a fan of these smoothing things. I always like pixelation. And I'm gonna go out here and say that I think we look better than Firefox. But that's really cool. Okay, so let's make some commits maybe. What do we got? For the image element, let's just add that it is helper by itself. So not this change, but this one. Lib web. Image elemente. Oh, wait, hold on. Oh, no, that's fine. And then what do we have? We have a whole bunch of things. Maybe we can make the image element wrapper by itself. So That one is fine. This guy and that guy. And the forwarding header, I feel like that was the change in there, so we add that. Oh, no. The make file, what was that? Okay. Do we have image element specific stuff? Yes, probably this guy right here is just choosing the image element wrapper. Okay. So libweb, I'll add a JavaScript wrapper for HTML image element. Okay, that's cool. And then really all that's left is just adding the drawImage API. So we only support one specific way of calling it for now, but that's okay. More can be added, more of the overloads. I guess that's one thing that's something I'm still like haven't figured out, which is putting me off or like making me put off code generation a little bit, because I didn't figure out yet how I want overload resolution to work for web APIs. Because when it comes to these functions that have like either 3 or 5 arguments, or like 3 or 5 or 9 and things like that, how should the code be structured in a situation like that? I need to figure that out. But at the same time, like if you write a code generator, you can sort of, I feel that when you write code generators, you can often allow yourself to write slightly uglier code than you would write by hand, because it doesn't matter so much. So maybe we will do some like horrendous if else spaghetti for the overload resolution. I don't know. We will see when we get there, but for now I'm just gathering data. So this will be our change, libweb. Add canvas rendering context to the drawImage, image XY. This function allows you to draw a loaded HTML image element, a loaded HTML image element into a canvas. I loaded. I gotta fit this into the into the 72 character space. Loaded IMG element into a canvas. There are various overloads. Oh, we don't have to mention that. But this is pretty neat. So we should probably add that little test page to the arsenal of test pages. And we'll link to it from the welcome page so that you can get there easily if you wanted to. Lie. A href. IMG canvas. Canvas draw image test. This, this welcome page with all of the test pages is kind of adorable. So let's see what it looks like with our little test included. Clickety click. Oh, I don't know what happened there. Sometimes it breaks at boot. Oh, I want to get rid of the alert, but oh, it is the home page right now. Let's fix both of those issues. So alert no more, and git add this guy and that guy, and git check out das browser, and rebuild and commit. And we'll say base, add a little test web page for Canvas, draw image. Cool. And there he is, the link to this test. Click. Very cool. I don't like that the title of the page says null, and also look at me with these broken DOMs. Or wait, is it even broken? No, the head ends here. Okay, so it just looked strange. Okay, not the most important thing, so we'll just say canvas draw image test. And then we have been good boys and added a title to the page, and we can enjoy that after rebooting. Gotta get those details right. Clickety-clack, look at that. Proper title and everything. So, I think this is gonna be the end of today's video. So, quite a quick one, but some nice functionality added, I think. The Canvas implementation, I really feel like the Canvas is such a great way to drive the development of JavaScript bindings and the integration between JavaScript and libweb, and also like the JavaScript engine itself, because you can get like a visual response to what you're doing, something that's kind of, you know, it's fine to work in the console, but here, like, if we can add more things, we can start to make very visual representations of the new functionality. So I don't know, I just like it. Anyways, that's it for the video. So if you made it this far, then thank you for watching and for hanging out. And I hope you saw something interesting. And I guess I'll see you next time.